Others were doing work on nitric oxide. It just started to do work on nitric oxide, which is a very unstable, poisonous gas in the Earth's atmosphere. So I was wondering, why are these people, there were only two of them, why are they studying nitric oxide? So I was following what they were doing, talking to them, and then I realized, maybe certain drugs that we take to treat disease may work through a nitric oxide mechanism. And I was thinking of that. And then one day, while teaching the pharmacology of blood pressure lowering drugs in class at Tulane Medical School, one of the medical students, after my lecture, asked me, I had just talked about nitroglycerin. Nitroglycerin is a drug, comes as a little tablet which you put under your tongue if you feel that you're having a heart attack, and it can actually save your life, by preventing that heart attack, relieving chest pain. So this medical student asked me what was the mechanism of action of nitroglycerin. I talked about what it does, but I did not talk about how it worked. And so the student asked me, she said, you didn't explain to us the mechanism of action of nitroglycerin. I understand nitroglycerin is also an explosive. She said, well, certainly it couldn't work by causing explosions. I remember the class laughing, and I said, no, of course not. I said, but I really am not certain about the mechanism of action. It may not be known. That's why I haven't told you why. Let me look it up. So I spent the rest of the afternoon reading up on nitroglycerin. The mechanism was completely unknown. Being a chemist, I looked at the chemistry of nitroglycerin. It's nitro. So it has actually 3 nitro groups, NO2 groups they're called, on this little molecule. And I'm thinking, I just wonder whether one or more of those NO2 groups in the body maybe is converted to NO, which is nitric oxide. So a couple of days later, we began to do those experiments in a laboratory. And after about 2 months of work, sure enough, we found that our arteries metabolize or convert nitroglycerin to nitric oxide. And so then we purchased some authentic nitric oxide gas, and we tested that pharmacologically, and we found that it produces all the identical effects of nitroglycerin. And so we concluded that nitric oxide is the active species in the drug nitroglycerin. We published that, and then many people repeated that work, and now we know how nitroglycerin works. Once we ordered the authentic nitric oxide, and we found that it was a vasodilator. It dilated the arteries, just like nitroglycerin. We then tested this nitric oxide further, and we found that it could lower the blood pressure. We found that it could prevent stroke. It could actually prevent, we have certain cells or elements in the blood called platelets. And when they aggregate or clump together, they could block arterial blood flow. And if that occurs in the brain, that's a stroke. If it occurs in the heart, it's a heart attack. So we found that nitric oxide was very, very powerful in preventing that. Okay? Then we synthesized some chemical molecules that make it a lot easier to test nitric oxide. Nitric oxide is a gas, very hard to add gases to your testing systems. So we had a solid material that had the nitric oxide built into it. So when you put it in solution, it releases the NO, or the nitric oxide. So we could do a lot of experiments with that. So we had published many papers showing how powerful nitric oxide was to prevent all the cardiovascular diseases that we knew about: heart attack, stroke, it drops the blood pressure. We also found that it could prevent or slow down the development of atherosclerosis, or cholesterol plaques in arteries. Okay, so then I remember It was a Friday afternoon, 1985. We were thinking and discussing in the laboratory. I brought up to my group, I said, why do our bodies react so sensitively to an outside chemical like nitric oxide? I mean, we don't have nitric oxide in the body, we didn't think. And so why do our bodies have all this ability to react to this noxious outside chemical that could protect us against cardiovascular disease? And then that was the first time I thought, well, maybe our arteries, our bodies, produce nitric oxide. It's just that we don't know that yet. Nobody's tested that. So we set aside a series of experiments, very difficult experiments. It took a year, and we finally showed that our arteries can produce nitric oxide. So then it became clear that, yes, we have nitric oxide, and that we make it in order to protect ourselves against cardiovascular disease. That is the principal reason I was awarded the Nobel Prize. So it started with nitroglycerin, and then wound up with that discovery. After we had made the discovery that our arteries and many other parts of the body produce nitric oxide for the purpose of preventing cardiovascular problems, we had been studying a variety of other effects of nitric oxide. And I remember one day in 1990, a urologist friend of mine at UCLA asked me if I knew what the neurotransmitter was that stimulated erectile function. Okay, so every nerve releases a chemical, and that chemical stimulates something on the other side to produce an effect, a response. So there are nerves that go to the erectile tissue, both men and women, but the neurotransmitter, the chemical that incites that action, was not known. And that's why in 1990, for example, there were no drugs available whatsoever to treat erectile dysfunction. So when he asked me what the neurotransmitter was, I said, I don't know, but you're the urologist. You should know. You tell me what it is. And he said, it's not known. He asked me if it was possible to be nitric oxide. And I remember telling him, nah, it's impossible. Nitric oxide is a gas. There's no evidence that any neurotransmitter could ever be a gas. And I let it go. And then I caught myself a few days later thinking inside the box. And I thought it was important to think outside the box. That's what I had done before to show that nitric oxide was made by our arteries. And so I thought about what he said, and I went and I read all about neurotransmitters, and believe me, there was no evidence that a gas could ever be a neurotransmitter. So despite all that, I said, we're going to do the experiments anyway. So I went back to my urologist friend who gave us samples of erectile tissue from humans and animals, and we did the experiments. And within a couple of months, we found that the neurotransmitter was nitric oxide. And we published that, and I remember the study on humans was published in 1992, and that stimulated a lot of attention. I was conducting interviews for 2 days from every newspaper and magazine and TV station you can think of, because it was obvious that was an important finding, because the major question was, okay, now that we know what the neurotransmitter is, could this lead to orally useful drugs, to treat erectile dysfunction? And at the time, my answer was no, probably not, but hopefully it will. 6 years after that, in 1998, Pfizer announced that the FDA had approved the marketing of sildenafil, it was called, as Viagra. Viagra is the trade name. So the reason I bring that up is because Viagra works by increasing the action of nitric oxide. So years before we published our paper in 1992, Pfizer had developed this compound called sildenafil to elevate nitric oxide in the arteries to lower the blood pressure. And so when they tested that clinically, they found that it did lower the blood pressure, but you had to push the dose pretty high to lower the blood pressure. And what they found that is when they elevated the dose, it caused erections in the male volunteers. And so when the clinics reported that back to Pfizer didn't know what to do with that, so they immediately stopped further testing and put the drug back on the shelf and said, we can't deal with this. And so they stopped developing that drug. Then when we published our finding in 1992 about nitric oxide, being the neurotransmitter, they realized, oh my goodness, our sildenafil works by increasing nitric oxide in the erectile tissue. So they went back to the FDA, they filed a new drug application, and they then tested the drug for the treatment of ED. FDA fast-tracked that development. In 1996, Viagra was developed. So that's why I'm often referred to as the father of Viagra, which I can tell you was always humorous to everyone except my mother. She did not like that at all. I had made the decision to test the hypothesis that nitric oxide was a neurotransmitter. So that's where it all starts, even before doing the experiments. So then you have to do the experiments. And then you test nitric oxide. You add authentic nitric oxide. It produces a vasodilation of the erectile tissue. That's what the erectile response is. So we were happy with that. And there were other experiments we were happy with. But the key thing, and the most difficult thing to show, is that when the nerves attached to that erectile tissue are stimulated electronically with electrodes, will the nerve release nitric oxide? So we had to set up experiments to capture the neurotransmitter, to stabilize it, and identify it. And that first experiment that we attempted to do that worked positively, and we could see in the experiment we were doing that it was nitric oxide. So at that point, I was ecstatic, and I knew we had something the laboratory celebrated. And then, it took an hour to plan the next 3 years of experiments. That's how simple it was. Once you knew it was a neurotransmitter, you knew, we're scientists. We knew exactly what we had to do. And so one of my graduate students and two of my technicians then just proceeded to do experiments. The experiments took 2 to 3 years. But what I'm trying to say is it became obvious what we had to do to prove the whole story. And it was great. In March, this is hilarious, in March of 1998, that's when FDA approved the marketing of Viagra. March of 98. Well, October of 98 is when I received a phone call about the Nobel Prize in Physiology or Medicine for nitric oxide. So after I settled down from all the emotional aspects of being told that you're going to receive the Nobel Prize, I was thinking, okay, so Viagra was just marketed, and now comes the Nobel Prize. So I decided to look up the Nobel Committee. So I looked up all the members, because you could look it up, all the members of the Nobel Committee in Physiology or Medicine. And I found that the great majority of them were men over the age of 65. So it's hilarious. But I was assured in Stockholm in December that was not the main reason. In fact, the cutoff for my Nobel Prize research was actually 1986. So I received the Nobel Prize really for the discovery that the arteries make nitric oxide to protect us against cardiovascular disease, and that was 4 years before the neurotransmitter discovery. For the remaining years of my life and career, I'm going to spend to try to convince the American people and people throughout the world that we could markedly reduce the incidence of cardiovascular disease by just changing our lifestyles. So let me explain this. What the nitric oxide field has shown, not just me, but to many others in the area, is that our bodies make the most amount of nitric oxide when we eat a healthy diet, when we're not obese, when we don't have diabetes, and when we exercise at least several days a week, getting your heart rate up. There are hundreds and hundreds of publications on this. There's so many great publications. If you run or bicycle or play soccer or basketball or even walk fast, you can measure it. Your body makes much more nitric oxide. And remember what nitric oxide does. Protects you against heart disease. It also improves blood flow to all your muscles. That's why you make so much of it, to get blood flow to the muscles while you're exercising, because you need oxygen and nutrients. I can list 100 foods that boost nitric oxide production, ranging from fish oils, to antioxidants present in blueberries, pomegranate, to antioxidants present in red wine, spinach, Brussels sprouts. I mean, you name it. All those foods are healthy. All those foods need to be eaten. One needs to eat as little beef as possible. One should even reduce the amount of chicken you eat, and I can always get into detail about that. But a healthy diet plus calorie restriction plus exercise. If everyone started that when they were a teenager, it's never too late to start, don't get me wrong, but if everyone started that when they were a teenager or in their 20s, I dare say that we could cut deaths due to cardiovascular disease down fivefold. Right now, 70% of Americans suffer from some kind of cardiovascular disease. 95% of that is due to poor lifestyle. It's not don't let anybody tell you it's genes. Genes may account for 5%. Yeah, what about the other 95%? Genes is just an excuse. It's unhealthy lifestyle. So I really believe, and so do others working in this area, that we make nitric oxide as an anti-aging molecule to protect us against the development of cardiovascular disease. So if we could focus on promoting the production of nitric oxide, I maintain that we will be very healthy. And I'm going to try to get my point across until I'm blue in the face. My desire, my aim, and I don't know how to do it, is to have my own TV show, 1 hour a week, just so I can talk to the people, but most TV shows rather interview LeBron James or Yogi Berra or somebody, I mean, it's really a world about sports. And when you talk about maintaining your health, it's very difficult to get that information out. There are lots of experiments going on showing that in humans with Alzheimer's disease, certain regions of the brain, which develop plaques that are associated with Alzheimer's disease, have a marked deficiency in nitric oxide. So there are small pharmaceutical companies, small biotech companies, trying to develop medications that increase nitric oxide in the brain to try to either reverse or prevent progression of Alzheimer's disease. So yes, dementia perhaps can be treatable by promoting nitric oxide production. It's difficult for me to walk up to a person who is very obese and is eating a hamburger and having potato chips. It's difficult for me to ask them, why are you doing that? Don't you know that's very unhealthy? It's easier for me to go up to somebody who's smoking cigarettes and tell them, you should stop smoking. Don't you know that smoking kills? And they'll go, well, yes, I understand that smoking is dangerous. It might kill me. It might not. But, I have this habit and I keep smoking. But if I challenge a person who's eating a hamburger or French fries or potato chips, often I get the answer back, if eating a hamburger and eating fries and eating potato chips was so dangerous, why are there so many shops, so many stores that sell this? And so that's what I have to deal with. And I don't know how to, I don't know how to get back to them. And I try to explain that it is very unhealthy. They say, well, they love the hamburger, they love this, they love that. It's difficult to cook a healthy meal at home, I guess. Years ago, I think when most women, wives, if I may use that phrase, stayed home to cook, healthy for the family, I think there was far, far lower incidence of cardiovascular disease. We didn't have these fast food shops. But now that more and more women, of course, are out working and making a living and so on, there's no time to cook at home. And I think that that's how the fast food shops probably developed, or what sustained or drove them to develop. And now everybody's going out. Families are going out quite frequently to eat, and that food is just, it may taste good, but it's not healthy. It's not a home cooked meal. It's very addictive. I mean, I have to tell you that I admit, once a year, my wife and I, we look at each other and we say, well, let's not cook our healthy meal. Why don't we go out? And we whisper, why don't we go out next door and have a hamburger, fries, and a shake? And we do that once a year. And I have to tell you, it's delicious. There were many, many setbacks. I think 20% of all the experiments I ever did worked according to plan, and 80% didn't. And so that's very frustrating. However, there's a caveat there, and that is that many of those experiments that didn't work, I would ask myself, okay, why didn't it work? Well, did we do the experiment technically correctly? We have to be sure that no mistakes were made in the experimentation, so we repeat it, but the results were not what we expected. So I would go back and think about that and say, okay, this means our original hypothesis could not be correct because this experiment didn't work as planned. So let's rethink the hypothesis and change it, modify it, and let's do a different experiment. So many times those negative experiments turn out to be positive. And that helps you to think outside the box. But many scientists, they get frustrated when the experiments don't work, and they're so convinced that their hypothesis is correct that they won't do experiments to change it. And then they're stuck with an incorrect hypothesis. So you have to be fearless, as you said. You have to be fearless and you're after the truth. I don't care what it takes to get there. You just got to get there and find out what the truth is. When we had our first hypothesis that nitric oxide, lowers the blood pressure and does this and that, and was the active species of nitroglycerin, I wrote a large research grant, to further investigate the pharmacology of this noxious, poisonous gas. And it was the first grant that was turned down. It was totally refused. I didn't get it, okay? But I published some of that work anyway, and then a couple of other people reproduced that work and extended it, and then I went back and applied for that grant, and I got it funded, okay? So that was good. And then when I had the idea that our bodies may make nitric oxide, that grant was turned down. My first publication was turned down because it was thinking outside the box. No one thought it possible. How could our bodies make this poisonous gas? That's ridiculous. We would all die if our bodies made it. On and on and on. And one thing led to another. Paper got published. And then I raised more funds than I knew what to do with. And Alfred Nobel came through. So there. You have to really believe that what you're doing is correct, and don't let anything stand in your way to get there. I learned this. It's a very popular phrase, never give up. Okay, I learned that in sports because I was never a very big person, but I loved baseball and football, and I played that throughout grade school and high school and a little bit in college, but not much. Columbia didn't have much of a baseball or football team, but I did play sports and track and field, of course, when I was much younger. And it was always a struggle for me because of my smaller size than the others, but I never gave up. I just had to work harder, run harder, cut corners harder, but never gave up, and was pretty good at it. And so I applied the same principles when I was a scientist. And as a scientist, you have to adapt that thinking. Never give up. Because as soon as you give up, it's over. You can never give up. If you really believe in something, you've got to pursue it until you've convinced yourself with experimentation. Okay, you had a great idea, but it's just not going to work. It's not true. And that's happened to me. Now, most have worked, so that's good. But I've had some ideas which I thought were perfect, and they were not. You have to have trust in yourself, and you have to be what I found that in this profession. Now, I'm not saying other professions are not. What I'm saying is that in this research profession, you have to be incredibly honest to yourself and to others, because you're after the truth. And I think that a lot of people who conduct research, if the experiments don't work and don't work and don't work, and their jobs become at risk, they maybe tend to stretch the data. I don't mean falsify. No. I mean, they may interpret things a little differently just to get a publication. I never did that to myself. I mean, there are many times where we had volumes of data which I would not even write up for a publication because it didn't make sense. And as the years went by, I could fill in those missing gaps. I would take out that manuscript. I had to, put in the missing data, publish it, and there it was. So, it's you have to be very careful, and you have to be brutally honest to yourself. Absolutely. You have to be very honest, and you just, otherwise you're going to, wind up getting in trouble. And luckily, I've never had a student or a postdoctoral fellow or a visiting scientist who's gotten himself or herself into trouble. I said, if things don't work and you're frustrated, it's better to lose your job than it is to stretch your data, because somewhere down the line, when people cannot reproduce what you did, then you're in trouble. And that happens a lot. You can't just make up data, publish a good paper. You might feel good about it the first year, but then when other people try to reproduce your work and say you're wrong, you are in a lot of trouble. I think that what we've learned so far about genes, genetics, in pharmacology, that's going to be the wave of the future. What I envision seeing, and I'm sure you've heard this, but I read a lot, I talk to a lot of people. What I envision seeing, I think in 25 years, I really do, that as soon as a newborn comes to be, or even maternally, a newborn will be tested with a small sample, maybe cheek cells or something very non-invasive. The entire genome will be analyzed. Every defect that there is in the gene will be noticed, and then it'll be very clear as to what needs to be done to prevent that gene from developing. That is, to correct the genetic defect. So that person may not develop Alzheimer's disease. That person may not develop high blood pressure or whatever. I really see that coming. And that is going to be great for treating disease, preventing disease, but it'll create other problems because you're going to have a lot of 150-year-olds around. What are we going to do with all these people who are over 100 years old? And once we develop to that stage. So, but you can't let that limit your development. I think what you need to do first is try to prevent disease, treat disease, so that humans can live a healthy lifestyle. I mean, the purpose is not to keep a human alive as long as possible. No. Why should someone die at the age of 55 for heart disease? Why should someone at 60 develop Alzheimer's disease? If all those diseases can be avoided, I think everyone would live to 100 or 110, but live a very useful life until then. I see nothing wrong with that. A lot of antibiotic drugs, anti-infective drugs, have prevented deaths due to a variety of contagious diseases, and that's allowed people to live longer. I think treating patients who have high blood pressure with drugs to keep the blood pressure manageable, that has extended everyone's life. So drugs have helped, but the way to go is, in my opinion, preventive medicine. In the United States today, we don't think about preventive medicine. We talk about you go to the doctor when you're sick, and then this doctor tries to give you a drug to treat the disease. It's okay, but that's very limited in its application. The idea is to prevent getting the disease in the first place, and then you don't have to worry about treating the disease. Costs much less, but we have a lot of obstacles out there. Schools still don't teach preventive medicine. No, some may a little bit, but I find that schools hardly teach preventive medicine, and I'll give you $100 for every school you can find that has a nutrition course in the medical school. There's just very little of that. I find that to be very sad. I asked them about their research and what they're doing. And of course, I talked to their professors first because I don't want to embarrass anybody. And then I said, okay, you're doing this. And let me explain to you what I did. So I would explain to them what I did. And they would always have questions. How did you know about nitroglycerin and nitric oxide? How did you know to look to see if arteries make nitric oxide? How did you know to look in the nerves to see if they release nitric oxide as a neurotransmitter? How did you know? I said, I didn't. I mean, I developed this idea, and this was thinking outside the box, and I went and I tested that hypothesis. So what I tried to do, and it's very difficult, is look at their research, okay, and then suggest to them what they might do in thinking outside the box and go maybe in this direction in addition to this direction. And I've been doing that for about almost 10 years at 3 different universities. And in several cases, it's worked out very well. The graduates have done better, and they're very appreciative, they're very happy, and so on. But it's hard. It's hard to teach somebody to think outside the box. You know, it's something that almost comes naturally. It's very hard to instill in someone. You have to be completely and totally fearless, because if it doesn't work, it doesn't work. You know, it's okay. You're not going to be penalized for that. Sometimes the way funds are raised to do research throughout the world, especially in this country, make it difficult to think outside the box. For example, you work very hard to write a research application, let's say to the National Institutes of Health or any other organization. You write down exactly what you're going to do, why you're going to do it, the feasibility of each experiment, blah, 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 and you submit it. And then if you're lucky, because it's so hard to get funded these days, you'll get a few $100,000 to do your work. Well, 3 years later or 4 years later, you have to apply for a renewal to continue your research. So you better be able to show that you did those experiments and publish them. Otherwise, you're not going to get any more grants. So when do you think outside the box? And where do you get the money to do the experiments that are not planned here? So what I would do is you borrow from Peter to pay Paul. You know, so I have my grant. Okay, I got to go do this experiment. I use this money to do experiment outside the box. It works. That allows me to apply for a brand new grant, and I get funded, and then I pay this guy back. That's what you have to do. My parents were both Italian immigrants. My dad was born in Naples, Italy, and my mom was born in Sicily. And despite that, they married one another. They actually moved independently to New York, to Brooklyn in the 30s and in the 20s and 30s. They met each other in New York. They got married, and then I came along in 1941, and my brother came along in 1944. My father was a carpenter and shipbuilder in Italy, and when he moved to the U.S., he was a carpenter. at first. Then he became a contractor and helped to build some of the boardwalks on Long Island, but remained essentially as a carpenter working independently by himself. Neither my mother nor my father ever went to school. That means not even the first grade. They had zero formal education. When my dad moved to the U.S., it took him literally 40 years to learn how to speak and read a little bit of English. My mother was able to adapt more quickly. My mom took care of her 7 brothers and sisters most of the time. And then finally she she met my dad and they got married. And my father, being a Neapolitan the way he is, he said, Frances, that was her name, Frances, I do the working. I work as the carpenter. I come home and I want dinner every night. So she stayed home and cooked every night and raised her 2 sons. And eventually, later on, she got a job working in a department store when we grew up. Everybody seemed to like the Italians. As long as we were turning out some good food and music, everybody was happy. But now I did not personally experience any prejudices or discrimination, but I had seen others experience discrimination and prejudice against them in the Brooklyn, New York area. There's so many different immigrants. Many people made fun of other people, and that was very disturbing to me. I remember growing up as a child. I still remember as a very young child, my mom and dad speaking Italian, and I learned that even before I learned how to speak English, talking about we have to be sure that our children have the best education possible and so on and so forth. So even though they couldn't help me with any homework whatsoever, except maybe addition and subtraction, which my mother could do, my dad was still not so good at it. They just made sure that we went to school, we did our homework. My mom never missed a PTA meeting or anything like that. She always checked on us. And my brother and I were good students. I mean, she didn't force anything down us. We would come home and she'd give us a little snack and say, got to do your homework first, then you can go out and play. I used to love to play ball. And she would always say, Lou, first homework, and then you can go out and play ball. And that's what I did. So without pushing us, she, both of them guided us in the right direction. But it was not easy because there was no help, with homework. And whenever I had a problem, she would go around the neighborhood and find a neighbor who could help. She was very good at that. I was about 10 years old, and for some reason at 10 years old, I was interested in chemicals. And I'm not exactly sure why. Maybe I think one of the neighbors talked about everything having its basis in chemistry. Everything was made of a chemical. So I convinced my parents to buy me a chemistry set at the age of 10 years old. And I still remember it was a Gilbert chemistry set. I don't think they make them anymore. And so, no one could help me do the experiments. I would read the things as best I could. I think the chemistry set was for 14-year-olds and older. I was 10. But I was able to do the experiments, mix the chemicals. And, when you're 10 years old and you mix one clear solution into another clear solution and it turns red, it's very exciting. And then if you add a different chemical to it, turns blue. Well, that really got my attention. Or you might mix 2 clear solutions together and it forms a precipitate. In other words, a solid material just comes out of solution. That was of interest to me. And I kept pursuing that further and further. And then when I got into my young teenage years, I took it a step further because I wanted to make firecrackers and rocket fuel. But to do that, I needed chemicals that were not in a chemistry set.
I should say.
So I would walk into the local pharmacies. Pharmacies back then were very different. Medicines were not in bottles that they just poured into your own bottle. They had to make everything. And so I walked in there and I could see what ingredients they had. And so then I would have one of my neighbors, older brothers or even his father, go in and get me some of the chemicals. They didn't really know the dangers in some of these chemicals, and they would buy them. I would pay them for it, and then I would have what I needed to make little firecrackers, rocket fuel, and so on and so forth. And I got in trouble for that eventually. My father was a carpenter, so he would help me build a lightweight rocket out of wood, okay? And then I would line it with tin foil, we used to call it then. It's aluminum foil. And I would reinforce it, and I would actually make the powder, the rocket fuel, have a fuse, go out in the backyard, light it, and send it up. And believe me, they went up pretty high. In the initial testing of my firecrackers, I added, so what I made was gunpowder, okay? And you can buy those ingredients in the pharmacy. I mean, I won't go through the ingredients, but very, very simple. And so the first one I made was just a little too large. So to test it out, I just put it on the floor under one of our dressers in the basement. We used to rent the upper level, and then we lived in the basement, and so we had clothes in this dresser. And I lit that, and it actually blew apart the dresser. So, of course, my mother was ecstatic. I mean, she went crazy, really gave it to me. And I remember her saying, wait till your father comes home. Wait till your father comes home. And so I waited in trepidation. Then when he came home, he wanted to know how I did this in detail. So I explained to him what I did. And he looked at me and he said, son, don't do it again. And then he left. And I remember my mom chasing him saying, and his name was Jack. Jack, you're not going to scold your son? Look what he did. He said, but don't you understand? He did something that we don't know how to do. He's very creative. Leave him alone. He won't do it again. That's a true story. When I did the rocket fuel, he was very impressed with the way the rockets were going up, and he really helped me with that. And anything else I wanted to do that was related to science, he would allow me to do. I used to go out, and that's the chemistry side. I was interested in biology, so I would go out and I would look for small animals that had just died, and I would dissect them, to see what was on the inside. Now that drove my mother absolutely crazy. My dad had no problem with that whatsoever. And I recognized early on that if you look at the inside, for example, of a squirrel, you just open the abdomen, and if you look at the inside, it looks exactly like that of a human. How did I know that? Because I went to the library and got out a book on Gray's Anatomy, human anatomy, and I would open that up and I would say, look, Mom, here's the esophagus, here's the stomach, here's the small intestine, it's the same. And then eventually she knew I wasn't going to stop doing this, so she paid more attention. She realized what I was doing, and she would always remind me, well, hurry up and finish that and get rid of it before it starts to smell. Yes, Mom. I didn't read that many books for fun, and still today I don't do that. So I'm not a big book reader, which is rare for someone with an education. I was always interested in science and technology. And so, as a young child, even before taking these courses in high school, I would go to the library and just read up as much as I could on chemistry and biology. And I couldn't wait to eventually take those courses. And then, of course, I would drive the teachers crazy. When are you going to talk about this? When are you going to talk about that? That's, I read other things too. In school, you're assigned certain reading, but to go out and read books other than science and technology on my own, I didn't do much of that. I had all kinds of friends. I've always been an extrovert, so I like to make friends with a lot of different people. My high school was good, the Long Beach High School and grade school. I think the better people in the community, or the people who didn't get themselves in trouble, so to speak, attended that school. But there were a lot of other schools around, especially 5 or 6 or 8 miles away. And so, when you're friendly with someone, they have other friends and so on, and you meet these people. So, and they led a different kind of a life. They were walking around in the evening and doing this and that. And I remember one time I was pretty young. I don't think I was a teenager yet. Two of the fellas had this idea of walking into a candy store and then just kind of stealing and sneaking some candy bars out. And they asked me to come along, and I recognized that isn't the right thing to do. And I said, no, thanks. I think I'll just wait here. And sure enough, they went in. They came out with candy bars, running, and I did not run with them. So that's what I mean by the opportunity existed for me to, to hang around these fellas. But I knew better, so I didn't do it. In grade school, you're a child. So, I studied. I did okay. I was not a straight A student. In science and math, I was a straight A student. In English and history, I was a C student. Okay, so in high school, I grew up, and in those subjects where I had gotten C's, I would get B's, but then all the science and math courses, I would get A's. And I began to realize, how hard they worked to get me to that point. And I realized that in the last year of high school. That's when I got all A's and scored very high on what is called the New York State Regents examinations. Every high school in New York State, on the same day, the students have to take a test. And then they look at the results, and that's how they rank the schools. So Bronx High School of Science was number 1 and so on. And the school I went to was number 4. I did very well, and they were very pleased. And then I went on to college. I didn't think I was going to get accepted to Columbia College, but I did. And when I got in there, my goal and intention, besides getting an education, was to please my mom and dad. And then the first year I was afraid I might not be able to do that because I found it to be so difficult. What a school that was. But I did. I did very well, and that made them happy, and made me very happy. I can't remember any particular person in grade school, but in high school there were 2 or 3 very inspiring professors. Now, I haven't thought about this in a long time. I'm going to try to think of their names. There was the English professor for my 3rd and 4th years of high school. His name was Shanker, Dr. Shanker. I don't remember his first name, but I was not very good in English. The language, yes, but taking the course, no. I was much more interested in chemistry and physics and math. So he pointed out to me how important it was to be able to communicate in English, because I had told him I want to go into science. So he's the one who really turned me around. And by the end of the 3rd year, I was getting an A in English. And in the 4th year, on these special exams that I told you about, the New York State Regents exam, I scored one of the highest in the state. So he was so happy about that. He made that clear to my parents. So that was one person. And Dr. Hirsch was my mathematics teacher for at least 3 courses, maybe 4 in high school. And he was very good, and he really stimulated me to think and to go on, and taught me how to use numbers, how to use math. My major was pharmacology with a minor in physiology. Okay, I was always interested in the chemical aspects of biology. So pharmacology is the perfect discipline. But because of my interest in chemistry as a child, and chemistry all through high school and college, I decided to take some extra courses in chemistry and biochemistry during my graduate studies. And so I took an advanced enzymology course, and it was taught by Paul Boyer. And I remember that being the most difficult course I ever took in my life. And I remember that when I was done, I received, after the final exam, I had a 77 average out of 100, and he gave me an A. And I realized that he gave me an A because it was the second highest grade in the class. And what's funny about Paul Boyer is he was great. He made a lot of discoveries. And in 1997, 1 year before I received the Nobel Prize, Paul Boyer received the Nobel Prize. And Paul Boyer, by the way, had moved from Minnesota to UCLA way before I got there. He moved there in the 60s or 70s. I got there in 1985. And, we used to talk to each other all the time. And then in 97, when he was awarded the Nobel Prize, I was one of the first to go over there and congratulate him and so on and so forth. And then the next year, I got the Nobel Prize. So he comes over to my office congratulating me. And I remember telling him, I said, Paul, I'm so glad you got the prize before I did. Because he had taught me everything I knew many, many years before that. I studied enzymes for my entire research career from graduate school after Dr. Boyer taught me that up until my last experiments. Enzymes are proteins in the body that facilitate a lot of different reactions, and your body is loaded with different biochemical reactions, all mediated by enzymes. So I became an expert in enzymology and did almost every important study that I conducted and published involved enzymes of one type or another. And Paul and I often discuss this. He's about 94 or 95 years old, but he's still doing very well, and we meet once in a while to talk about the good days. When I was in high school, as I said before, I loved chemistry. So I was going to go and just get a degree in chemistry. And my dad, even though he had no education, says to me, he says, Lou, when you become a chemist, what are you going to do with that? I said, well, Dad, I'm not sure. Maybe I'll go work in a drug company. Maybe I will teach chemistry in a university. He said, okay. He said, doesn't a pharmacist know chemistry? I said, yeah. He said, well, if you go to pharmacy school, that's also chemistry, when you graduate, you could have a job right away, and then you can decide what you want to do after that. It's my dad, completely uneducated. Of course, he did, as a carpenter, did a lot of work for pharmacists in the pharmacies, in the stores, in their homes, and so on. So the net result was I went to pharmacy school, but I took 3 or 4 additional courses I didn't have to take in pure chemistry. So I graduated with a degree in pharmacy and chemistry, and I used that to move forward. I worked in a pharmacy in the summer after my 3rd year in pharmacy school, which is what everyone did if you were in pharmacy school. And so my job was to really stock the shelves and watch what they were doing in terms of filling prescriptions. I mean, I was not old enough or advanced enough to actually fill the prescriptions, but they gave me some opportunity to do a little bit of that. But to make a long story short, after 3 months, I recognized that after all the education I had received in college, that it was just inadequate for me to simply fill prescriptions. It just wasn't, for me. I was not a businessman, and in those days, if you owned your own pharmacy, you make good money. But I wasn't thinking that. I was really thinking more of research in chemistry and biology. And so I knew right away after my 3rd year that once I finished pharmacy school, I was going to go on to get a PhD in either chemistry or pharmacology. So in my senior year, again, I worked in the pharmacy. This time they allowed me to fill some prescriptions, but it wasn't for me. So right after the last summer, I decided that I was not going to practice pharmacy, and I had already applied to graduate school to the University of Minnesota for the Department of Pharmacology. So that's what I decided to pursue, and I'm very happy that I did that. I found that to be very rewarding. The American dream, to me, means it signifies how successful a citizen of the United States can be if you really take advantage of all the things that America has to offer. You know, we have great freedoms here. We have the ability, capacity to go to whatever schools we want to go to, provided we do well and educate ourselves in order to get into those schools. But I guess what I'm trying to say is there's still, even today, so many different opportunities in the U.S. I think the majority of the universities and higher schools of learning in the U.S. Surpass those in other parts of the world. There are great opportunities here to take on any kind of profession. And then once you finish schooling, there's so many opportunities for great jobs here. The United States is, I think, synonymous with science and technology. Now, there are great advances, don't get me wrong, in Europe and especially in Asia, but still I think the center of attraction for science and technology, which I can speak to, is right here in America. And so for those who are interested, I mean, they could take the opportunity or they can use this to their advantage and really learn something and excel in science and technology. Research, biomedical research, if you're not highly motivated, but you do it because it's a job, those individuals don't think outside the box. They just read up in the literature and they see what has developed, so they'll know what direction to go to extend, our knowledge in a particular area. I did a lot of that, but that never made me happy. I didn't want to extend what we knew about an area. I wanted to discover something new. That's the way I always was. And not because I wanted to be number one or be first. No, that's competition. I compete only against myself. I never compete against anyone else. So that wasn't the intent. The intent was there's so much information to be learned out there. There's so much to be learned. Okay, so if I just follow in the footsteps of others, I'm not going to be able to make those discoveries and learn all the new things out there. So I took every opportunity I had to think outside the box and go somewhere where no one else has been, if I may plagiarize that show. And so that's what I've always done in my career. My father never went to school, okay, but he was a carpenter. And in the summers, before going to college, he took me to work with him so I could help him on his job. And I could see what he could do, being completely uneducated. And also, by the way, in those days, no such thing as a power tool. You didn't plug anything in. You used a saw, a hammer, chisel, nails, a screwdriver, a drill. I mean, nothing. There were no power tools. And I watched what he did, and I was always impressed, but I never thought about it till many, many, many years later. I remember that he could draw a perfect circle without a compass. He could draw a straight line, perfectly straight line, using his thumb and placing the pencil in a certain way. I mean, all these things, he had his own designs he added to windows and other things. So I think that's creative. So I'm creative, so that creativity had to come from somewhere. And my brother and I concluded, although we loved our mother dearly, the creativity had to come from our father. I'm retiring now from my original research, but I started a company in which I deal with other companies trying to help them develop nutritional supplements rich in antioxidants and other things. So I'm trying to take my ideas to a different level. But I stay motivated. I try to stay motivated in a variety of other areas. I am a visiting professor in several universities, so I visit several countries often, and I work with those students to try to teach them how to be original and think outside the box. I have gone back to revisit two hobbies I had when I was a young child and a teenager. So now I'm back into owning racing cars. I used to race cars when I was a teenager. So now I have one of the fastest production cars ever made, although I don't race it at the track. I also don't race it in the street, by the way. I just like to have it. But the key thing I have done to stay motivated is when I was a young child, even before getting my first chemistry set, I convinced my dad to buy me a model railroad made by Lionel. And I had model trains, a small set we put around the Christmas tree, and then eventually I built it in the basement. So today I have a huge garage. It's not for parking cars, but I have a very large model railroad layout that I've built and maintained, and I've been working on it for about 7 years. And it's been in all kinds of magazines and videos and so on. I love to do that. And by the way, the Nobel Foundation has told me that I am the only Nobel laureate they're aware of who has a model railroad. The one thing about research being very exciting is the fact that you really don't know what to expect. So you have to be very creative. You have to be able to ask the right questions and then answer them in a timely manner. And then once you get answers back, you need to know what direction you're going to go into next. Okay? It sounds very exciting, but it can be very frustrating. Because, for example, in the laboratory, when you're conducting experiments, not all experiments work, or they don't work the way you thought they were going to work. Okay, so now what do? Research carries with it a great deal of frustration. There's no instant gratification in research. You do an experiment, okay, fine. Now you take it in this direction, you take it in that direction. You may not know if your project has been successful or if you've made an important finding for a year or 2 or 3 years. So that's what I mean by no instant gratification. In most aspects, sometimes there have been experiments where there was that instant gratification. But at the beginning, it's very frustrating. It takes many, many hours. Doing original research in a laboratory does not mean that you go in at 8 in the morning and you go home at 5 in the afternoon and you take weekends off. Sorry, that's not the way it works. You may be going at 6 in the morning, you may be staying until midnight. I've always worked on weekends, at least the first 20 years of my career. And depending on the experiment, sometimes you have to stay awake for 24 to 48 hours, depending upon what you're doing to monitor the experiments. Also, to do experiments, you need money. Just because you have a position in a university does not mean that you have money to do research. Universities will accept you so that you can be an instructor, an assistant professor, associate professor, professor. So what do they provide? Well, they give you an office and they give you laboratory space, and that's it. It's up to you to stock the laboratory with equipment. It's up to you to raise money, to hire technicians, nurses, other people you may need. It's up to you to get the money to hire a secretary. School provides none of that. They give you the opportunity and the space to be successful, and then you're on your own. So you spend a great deal of time raising funds to conduct the research. So it's not easy. The principal investigator, which is me, let's say, we have to do it all. You know, I had to do everything. And then you have other obligations. You're not at a university just to do research. You're at a university to teach students. So I was teaching undergraduate students, I was teaching graduate students, and I was teaching medical students. I loved to teach medical students, so I did that for many, many years. I think the best thing that makes science exciting is that you have the opportunity to think about important questions in science, whether it's science, technology, medicine, chemistry, whatever it is. You have the opportunity to think about important and exciting questions. You have the opportunity to then try to answer those questions, and it's up to you. In other words, everything was up to me. So everything is up to you. You can design the experiments, you test the hypothesis, you look at the data, you draw the conclusions, and then you go from there. And the greatest thing about all of this is when you're able to answer a question satisfactorily, and you've made an important contribution to humankind. I said, and even if it's not an important contribution to humankind, even if you've answered your own question satisfactorily and you could publish it somewhere, I said that's very gratifying, and that's a great reward in life, because it's one profession where you could have a lot of those rewards, but you do have to work hard.